Welcome to the lesson video on exploratory data analysis. In this video, we're going to talk about exploratory data analysis, which is the process of exploring the data to summarize its main characteristics. Usually this involves visual methods and not modeling relationships between inputs and outputs. It can also involve looking for missing values and distributions of the variables and things that will be helpful when you go to predictive modeling. Why would we do exploratory data analysis? Well, it generally just helps us learn the basic nature of the data. So you may uncover relationships that are important on their own that you wouldn't notice doing just the predictive modeling. So you can uncover things that are intrinsically useful or important to your application by themselves. You also can uncover things that are helpful for doing your modeling and prediction to help choose your type of classification method and optimize your parameters and your expectations. So let's look at a simple example. We will see more tools for exploratory data analysis as we go on using different types of visualizations and clustering methods. But just as using the simple method of scatter plots, we can learn a lot about our data through exploratory data analysis. So choosing a red pen, this is the Fisher's iris data. So with three varieties of iris flowers and 4 different measurements for each flower. So if we just look at this data, there's a couple of things you can see fairly quickly. There's these 2 features, petal width and petal length, that seem fairly highly correlated. We also observe that there is a separation between the red class and the blue and the green. In this case, the red class just seems generally smaller. It has a smaller width and smaller length than the blue and the green. And in most of our feature variables, there's a fairly good separation between the red class and the blue and the green. Whereas on the other hand, it seems difficult to separate the blue and the green robustly. And in this plot, using these 2 features, we see a lot of overlap between the blue and the green. Looking at these plots, we might also estimate that these variables seem to have a reasonably Gaussian distribution. So this might suggest to me linear discriminant analysis or possibly quadratic discriminant analysis as a classification method on this data. Look at a little more data just using scatter plots. So first on the left-hand side, we have the Boston data set. And one of the things that I observed that should pop out to you fairly quickly is that there are a lot of nonlinear relationships in this data. So if I was going to try to use this data to do some form of regression, I would want to use something that would allow me to capture those nonlinear relationships. Other things is that there are some distributions where there's a dense area of data in one area and then the data is sparse and more spread out as you go away. There's also places where this data seems to max out at some maximum value, and we get some funny geometry structures in here that may correspond to the tax variable, so it may be tax brackets or something like that. We see them here as well, and there's some odd vertical categories there. So those are the kind of things that we would look at just looking at scatter plots. Over here, you'll observe there's one group of data down there and a separate cluster along the line up here. I don't know what that is, but it would be interesting to know. It tells us something about what's going on in our data. On the right-hand side, in the headers data set, this data set, most pairs of variables have some positive correlation, and there seems to be a linear relationship between most pairs. Maybe a little bit here that's nonlinear, right there. But in most cases, there's a fairly linear relationship, and there's not a lot else going on in that data that jumps out just looking at the scatter plots. So this is a type of things that we look for in exploratory data analysis. Remember, you can find things that are important on their own, or you can find things that help you do better predictive modeling, or find things that help improve your data, missing values, odd values that pop up, those sorts of things. Thank you for watching.